Welcome to Using What They Know, a workshop for College Board AP Computer Science Principals Consultants about how you can support students during this time with things they are already using and about which they can bring some prior knowledge. My name is Eric Alata. I teach computer science in New York City at the Academy for Software Engineering. We're a small public school, and I teach the first half of AP Computer Science Principles to all ninth graders. I have 135 students who range from across New York City in terms of their locations, backgrounds, skills, and ambitions. 20% of my students who enroll in our school are female. 70% of our families have low income. We've been teaching computer science principles at AFC for a pretty long time, with lots of different twists and turns and different things that we've tried. We actually started as one of the first pilot schools many years ago. So some of the things in this workshop are resources and concepts that I've brought with me from different curricula. We've tried many different programs and tools and programming languages, but this year we focused on teaching computer science without overwhelming students, by making sure that we were supporting what they needed for their core subjects. Foundational skills like document formatting and email processing are needed before adding specialized content. This is especially true for my ninth graders, who I've never met and in most cases have never seen. Right now, it's really helpful to think about what are the tools that students already know. I'll add as a caveat to this talk that I have pretty low attendance and low work product submission. To be honest, I've never had great numbers, but this has been an especially tough year for students in New York City. I'm especially focused on making sure I keep as many students feeling successful as possible. Some of the ideas in this talk wouldn't be full-blown units in a before times school year, but I have used them as full-blown units this year. At the same time, I think I'm getting some insight into how to build from the assets that students are bringing to the classroom that I hope to keep in future years. The first thing we're going to look at is web publishing using Google Docs. With Google Docs, we're using a tool that students have potentially been using for a long time. Maybe it's not Google, and I'm not promoting Google or any other platform, but the basic functionality of a word processor that can publish its content as an HTML file is something that most or all of our students are going to have some exposure to. However, students might have been using Docs. Many of our students have possibly no prior knowledge with creating from scratch. I remember back when I started teaching computer science principles, we were at the beginning of the Google Docs revolution. I did workshops for the pilot teachers on this very subject. Soon, everything I did became a pre-formatted Google Doc that looked like a verbose web form. Our hearts were in the right place. We needed a better way of getting students to fill things out that could also bring some efficiency to evaluating student work. At the same time, managing student work by giving them everything pre-formatted, we weren't necessarily supporting the creativity and empowerment of our young people. Computer science has the opportunity to take Docs as a tool and expose students to the power of the tool in ways that can enlighten the structure of content. A little bit of design thinking and graphic design make the projects fun, but also thinking about the structure of a page in terms of what will later become the structure of the data of that page that could be read by another program lays a foundation that will help students engage more deeply with programming in the future. We can talk about how HTML is not a programming language, and we don't want to confuse students. But HTML is a nice introduction to syntax that we can have students write and look at before we get into text-based computer languages. But HTML is also the data, and its structure allows us to insert other data. It's the structure of the HTML as data that we want to keep in the back of our minds. While the structure of data is something I want to talk about with students and give them exposure to early on, mostly I want to get them making. I want to get them doing things in my classroom without having to teach much to do it. I've always struggled with low engagement in terms of work product, especially this year. And this year we have especially low attendance for a course like the Intro to Computer Science for ninth graders. Lowering the bar to produce anything and then celebrating that thing is an essential teacher move for my classroom. Starting with Google Docs and giving structure to a blank page is one way to do that something. The first thing I like to talk about when we get into a Google Doc is that Google Docs are structured to look like a piece of paper. They have a ruler at the top margins and start off white. However, we're not really going to use this as a piece of paper. Even when we were back in the school building, we rarely printed out Google Docs. Instead of thinking of them as a piece of paper, we could think of them as a canvas. In this case, we want to think of it as a canvas for web publishing. Many of my colleagues don't even realize that they can change document style and organization using structures like headings. Styling using document structure is another way that we can get at underlying concepts of abstraction while supporting students with what they already need to be thinking about for other classes. When you go to the File menu of a doc, you'll see a couple of options. One of the options is the Publish to the Web option. So what is the difference between a web page and a Google Doc, I might ask my students. Most students will be able to talk about how only certain people can see a doc. They may also mention that a doc is for editing while a published page is for viewing. You can either get a link or an embeddable piece of HTML script. We're going to click the Publish button under Link, and once you do that, you'll get a link that goes directly to that published page. It will end in the letters PUB. I tell the students to look for PUB. That's the link that I want them to submit. Having students submit a published link to their doc ensures that I will be able to see the page, which is one reason we started creating templated auto-shared docs in the first place. Some more options we can use to set up our doc as a canvas are under Page Setup. We can start by changing the background color and taking away some of the margins. Choosing font and font size and color can also help students start to see different possibilities. Most of our class time is facilitated by sharing and celebrating cool things that students make, anything that increases student ownership and engagement. I'm trying to support skills like being organized about when you have to go to class and where to find the resources that you need for that class. You can add links to resources folders, links to Google Classroom calendars. I got to think more about what students are actually coming in with. The knowledge of a hyperlink, for example, is not common knowledge. Students know about links, but that you can be working in a document and can take some text and you can turn that text into a hyperlink to go somewhere else, that was not something that students came in with. In every other year, I assumed that was common knowledge. This year, I got to find out that it wasn't. I guess what I'm saying is to check for understanding around topics that you might want to assume. It doesn't do anyone any good to skip the basics. I do have a few students who have more experience, but I'm much more concerned right now on being widely accessible to the largest number of students. It's fair to ask what we are doing for students who come in with prior knowledge and higher level skills. And I know the debate about using students as tutors to support other students, or should we send them ahead and let them accelerate as fast as possible? I've gone back and forth over the years and tried different things. On one hand, students are not teachers. It's not really fair to ask them to be teachers. On the other hand, it helps them explain concepts to other students. Facilitating conversations between students is always extremely valuable, but has been hard for me to do this year. At the same time, we're trying to create a community. For even my most accelerated students, I say that formatting a document is a pretty important skill, and it's not beneath anyone. And even my most accelerated students have lots of room for growth around creating good formatted documents. I tell them I want to see what you can do. I don't want you to tell me that this is easy. I want you to show me what you can do. Then show it off to other people and let them learn from it. Everybody does this, and even my highest performing students are doing it and putting in lots of effort to make it look cool. I spend class time sharing what students are capable of. We know that over the course of a CS Principles experience, we want to work with data. Through tables and programs and computing innovation research, we are exploring the transformations of data. Knowledge of data underpins the entire computer science principles concept. Since we are going to want to do lots of work with data throughout a CS Principles course, we're going to want to introduce the structure of data, especially data that is tabular in nature. We're going to want to have them use tables to organize content, to develop algorithms, and to analyze data. We probably want to get started just talking about what are some of the basic features of a table. Each column has a header that names the column. Each row is data about something. In a schedule, each row could be a period of a class or an hour of the day. In a monthly calendar, each row is a week. Each column is a property of something in that row. We want to give students autonomy as soon as possible, no matter what tool we're using. And one of the easiest forms of autonomy is choosing the color. We want to talk about formatting because these things are fun to use, and students get motivated by having some control right away. However, we also want students to make choices that underlie important concepts whenever possible. We want to use colors to illustrate the structures that we want to bring up. In this case, the structure of a table. If you right-click on a table and go into the table's properties, you can start to edit things about the table. Let's put everything that's in the header of the table centered into the middle of the cell. We can also talk about the padding, which is the space on the inside of the cell. Margins are the spaces around things, like the layers of an onion. A little bit of formatting, and then we can start to put things into the data rows of the table, like I had my students put links to their class meetings. Using color to illustrate the structure as opposed to just changing background color, which is design, helps think about structure and supports understanding data of pages, data of calendars, data of email, and the difference between data and metadata. These things aren't video games, but the stuff is so immediately useful that there is engagement. I say better to have a slow building engagement from confidence than lots of flash at the beginning that turns into drudgery. After the first few times working on our Google Doc websites, students noticed that the output web page did not always look like the original doc, especially when using inline images. From here, we then learned to put the entire content of the doc into a table, and use the table and the merge cell features to structure the entire page. This gives us more control over the layout. We could also put tables inside of tables. We create a title banner, an area for a welcome message, an area for navigation links. We then learned how we can hide the borders of a table by right-clicking on the table and going back to the table properties and setting the border thickness to 0 to make them disappear. The HTML file that is produced by the publish to the web function contains the table structure from our docs. We can look at the HTML of the publish page to notice that. Using the merge cell feature to control layout creates something that looks more like the structure of a web page that students were familiar with. Using a table is using a structure that HTML has, so the HTML will then have that table structure in it. So it's more likely that what you saw on your Google Doc would look the same on your HTML. Noticing HTML structure before writing their own code is a less intimidating entry point. Doc publishing is returning an HTML file. So we're also bringing up this issue of translating data and that a computer program translates data from one form to another. We're taking one kind of data and translating it into another and then using data to render an image or cause some output to occur. HTML is input data used by a program like a web browser that then uses results of that program to change some bit of screen. Computer programs use data to produce other data and can produce a side effect or cause a computer process to occur. Going back to the publish to the web option to get our link takes a few minutes to republish the changes, so we'll get to see what actually did get published. We can extend the doc creating activity by asking students to take assignments that they're working on for other teachers that might have been pre-formatted and reproducing their own work with some style, and then publishing for presenting to others. Let's turn our attention to the next tool. After some time of creating docs and giving students time to actually develop their ability to format and lay out a document, students are ready to graduate to a more powerful tool. They can graduate from docs to a more powerful web builder like Google Sites or Wix or Weebly. It's very helpful to use whatever ecosystem my school is in. If I'm in the Google world, it's just so much easier for me to use whatever the ecosystem is, and to use the tools that students already have access to get as much out of those as I possibly can. If I was in a Microsoft school or if I was in some other system, whatever makes most sense, I would just try to use that. Maybe there's a web builder for that ecosystem, or I would find whatever was the easiest way that you can create a web page would be my next question. There's a great benefit to just getting students to make anything, then encourage iteration. We do want to graduate to a more powerful tool where it is easier to add content and pages. However, I do like to start with a more manual technique and maybe a slightly more difficult technique and then show an easier way later. I do always get groans. "Mister, why don't you show us this before?" But I'm still a believer. Sometimes there are really easy ways to do things that cover up a little bit of what's going on, and I don't want to hide that entirely. For example, creating 2 pages and creating links from one page to another so they can go back and forth exposes the idea that the web is just a series of linked documents. Also, I just think it's a good skill to be able to format a Google Doc. I want to support fundamental skills and habits, and then add on tools as we become familiar that give students more power. When they're ready for it, they really appreciate the power of the new tool, and you can really see students typically go much faster the second and third time they go to a new tool if we started with something they're already familiar with and just get them making. Their Google site is going to be where they submit work going forward, and I'm encouraging other teachers to use their site to have them submit work through the Google site for groups of students who do it. Remember, I said like 50% of my students are really doing those kinds of assignments, like setting up a new Google site the first time I ask. And for that 50%, they can already be getting assignments from other teachers and starting to build out something of a professional portfolio site. And then the other 50%, where I'm not getting that right away, they need to spend more time and need more one-on-one attention. It's not going to be something that they do right away, but the option is there for other teachers. Go to sites.google.com and click the plus button. The first thing I'd ask students to do is to create a title. Once there's a title in place, then the publish button is active, and that's all they need to do to get a site published. I have to complete the web address, and once I decide what that's going to be, I can publish it. Once I've got a published site, I can click on the menu next to the publish button to view the published site, or I can click the link icon to copy the published address. This link is what I want students to submit. The next thing would be to add a page to the site. The Pages tab allows us to create a new page with the plus button at the bottom of the screen. Students often miss where that is. Now that they've got screenshots page, they can start adding images to that page through the insert options here. You can also double click on the page, which is really cool. Picking out an image, you could search for a Google image, or I have them add screenshots from their own computers. I could add some reflection text about something that we're working on, or whatever we're submitting. This would be a way they can both be submitting it to me, but also thinking about what it would look like to publish something for a wider audience. I like having students publish work right away, especially publishing work in progress. Giving them a sense of growth is very helpful. They have more confidence for trying in the future if they're rewarded for taking lots of baby steps. Anything they can really hang their hat on and show growth supports future attempts. As we're working on publishing, we can fill out our class with more computing content by using the Computing in the News activity and news aggregators like ACM Tech News. Students start looking at headlines of articles and then eventually dig deeper into the articles and into the concepts in the articles. This is an idea that came from those early days of CSP through the Beauty and Joy of Computing curriculum. BJC uses the Computing in the News opener at the beginning of every class. Computing in the News exposes students to computing concepts on a regular basis in the context of what's currently happening in the world of technology. Tech News is a great website, but there's lots of technology and scientific news aggregators, so mixing up where the articles are coming from is also helpful for engagement. You can eventually have students look on the open web for sources, but I do think it's very important to start with curated sources. Tech News has a daily list of interesting headlines, and I like to just start with the headlines themselves. Get students to pick out a headline that they find interesting, and then take time to decode the headline as a class. There are always going to be references in the headlines that students may not know. Headlines are also nice because they are short, and also crafting a good one takes a lot of thinking, usually referring to some knowledge or interest that you assume in your audience. Later in our data science unit, we create our own headlines from the New York Times What's Going On in this Graph activity. I remember this headline about DNA tricorders, which assumed you had knowledge of Star Trek. They don't. My students don't have knowledge of Star Trek because we're old. That's why. Getting them to think about headlines and maybe having to fill in some knowledge or prompting them to notice that they didn't know something and then sending them to go find out can provide a broad entry point in empowered decision making. The opener can lead to more in-depth work on that article. You can then start to have them read and annotate for computing concepts. Especially after you get into computer programming and input-output transformations, then finding where the computing lies in those articles becomes easier to talk about. It's nice to just get the conversation started. Computing conversations are always going to be about data. What's going on with data in our news, data used for artificial intelligence and machine learning, and all the ways that it's being deployed, and data used for analysis about ourselves. Those are the topics that can get started on day one before any programming. The student-created websites are obviously a great place for them to start putting their reflections about their articles and to tell us what they're thinking. Making any connections between any two articles is also a fantastic activity, and we really want to celebrate any student who can find connections. A very simple activity, but we can do a lot with it. The last tool that I'm going to talk about today is Gmail, which is a tool that every student needs to use, but not every student knows how to use. If I'm trying to build up computing knowledge with a student that doesn't understand the basic functionality of Gmail, I think I'm being irresponsible if I don't start here. Our students have a school-generated Gmail account. We discovered while learning about Gmail that students' accounts receive about 8 messages per day, which means that if they didn't check their email through all last semester, which most of them either didn't ever check or checked but didn't do anything with the messages will just pile up in the inbox. This means that most 9th graders had between 800 and 1,000 messages from the beginning of the year when the accounts were created in the fall. What are you going to do with 1,000 messages? We also noticed that most, really more than 90% of emails that are received by 9th graders were the result of a computer program notifying them of some activity. Email generated by computer programs such as Google Classroom notifications, automated attendance reports, or advertising spam create noise that discourages students from responding to important messages. We can help students with a combination of habits and understanding. We begin by learning the basics of how Gmail works. First, we notice that there's an inbox. And if you scroll down on the left side, there's also an area called All Mail. In All Mail, you can see messages that might no longer be in the inbox, which means that they've been archived. Let's put this message back in the inbox. I'm going to select that message and then use the Move to Inbox button. When you click to open a message, you can see something about what it means to be in the inbox. Right next to the title, we see a display of a little bit of extra data. When a message comes into your mail, it's given this tag, inbox. Students are familiar with this concept. It's a hashtag. They'll come up with that idea on their own. We add a little bit of extra data because it makes it easier for us to work with a group of messages at the same time. When I only want some messages but not others, like when I'm viewing all messages that contain a hashtag, that is called filtering. I then need to decide to take one of three actions with each email: delete, read and archive, or star and archive. We don't need to read all of our messages. We can tell right away when a message can be deleted from the subject or the first line. Starring is for messages that we need to think about or take more time to follow up on. Reading is for messages that are personal, from another person. Once I've decided what to do with a message, I want to take off this little bit of inbox data. Clicking on the X next to the label removes the inbox label, so now it's no longer in the inbox, though it's still here in all mail. It's exactly the same, moving it back into the inbox, as this button here, which is called archive, which is just a word for remove the inbox label. And that's the next thing we want to learn. Archive equals remove the inbox label. Now the students have 800 messages built up, so imagine that this is not just one message, but it's 800 messages. They need to select all of the messages to do an Amnesty Day archive. The first archive is called Amnesty Day, which means we archive, not delete, all messages in the inbox. Selecting all messages is the empty checkbox in the upper left corner, but it won't select past the first page, so you have to click the drop-down menu next to that and select all. A message will pop up asking whether you really want to select all 800 messages, which we do, and that's how you archive truly all messages to get started learning to process your inbox. We then process messages daily that come in until the inbox is empty. Students submit me a screenshot of the empty inbox. We can then get into things like settings. I want them to be aware of settings and to be aware of the control that they have. Gmail is an incredibly powerful tool for managing and filtering data. This could lead to other units where we start making our own email machines by having columns for subject, to, from, and date. Then we can start filtering those based on some date or ranges, or based on some metadata. That would be a very simple thing to do as a spreadsheet activity. That would be the next thing after this, which I'm not going to cover in this presentation, but spreadsheets unit. Getting students to analyze their own data, like grades and attendance, looking at anonymized data from across our school, and eventually our data science unit, which uses a programming language to analyze real-world data related to student interests. Spreadsheets are the next tool that they would very likely be able to use right away and in multiple contexts. I want students to see and reflect on different things in the Gmail settings, like stars. Setting up your own stars is something that's fun for students and very important as you're becoming an email processor. Setting up your own personal labeling system. Stars are labels that are very fast to add. You can add text labels, of course, but we also want to be able to really quickly do fast processing. Then we can go back and be more careful or detailed. We could set up automations that automatically check for certain things and give them certain labels. When you start off with a Gmail, you have keyboard shortcuts are turned off. We do want to have those keyboard shortcuts turned on. And then we'll learn the first basic key bindings, which are S for star, E for archive, and Shift-3 for delete. Hash sends to the trash. X is for select. To archive or delete, you have to select a message. To star an email, you don't have to select it. Once you make a change to your settings, you have to scroll all the way down and click Save Changes. There's the habit of daily processing that I want to reinforce, where students are just getting to know how to use the tool itself, getting to develop the habits for that tool daily. Then there's the computer science of the tool, the filtering of data. They can think about that as they're developing their habits by adding on this kind of thinking. When we ask students to reflect on concepts while building up a habit or a skill that they really need to know, I feel we are supporting the development of a more complete student. At this particular time, when we have pronounced trauma in the lives of students, when we have learning loss and lack of continuity, it's very important to support students as whole students, not just add on an entirely different subject with new nomenclatures and idiosyncrasies. One of the things about computer science that can be intimidating and really off-putting is our jargon, and can make it more difficult for students from communities underrepresented in computer science to engage. All that jargon is just hurdles. We know what the concepts are. Let's use the language and tools that students already need to know, and support finding the connections as our first priority. Then let the technical verbiage and the nuances of programming itself pave over a foundation that we have made together. Thank you so much for working with me today. It's fantastic to get to talk to you and to share some of this work from my classroom. I look forward to our live session and digging into other possibilities for supporting our students. Bye.